Have you ever contemplated whether we're truly alone in the universe, or if there's another component to our reality beyond what we see? Imagine if the James Webb Telescope finally revealed that we live inside a black hole. Join us as we explore this fundamental news that could make you question everything you thought you knew about the universe. So, what exactly are black holes? They're like something out of a nightmare. Sure, you may have seen them in sci-fi movies, but they're far more terrifying than that. As described by scientists, black holes are objects in space that contain enormous amounts of matter packed into a tiny area. Picture a star several times larger than the Sun, compressed into a space the size of New York City. The gravitational pull is so intense that nothing, not even light, can escape from it. Scientists have been fascinated by black holes for years. They've studied objects in space so massive and dense that they can trap light. The most famous theories about black holes were predicted by Einstein's theory of general relativity. Essentially, when a massive star reaches the end of its life, it collapses, leaving behind a dense core. If this core's mass is several times that of the Sun, gravity overpowers everything, leading to the formation of a black hole. It's difficult to detect black holes because they emit no light. However, scientists have found ways to infer their presence by observing their effects on surrounding matter. For example, if a black hole moves through a cloud of interstellar matter, it pulls that matter toward it in a process known as accretion. Additionally, when a normal star gets too close to a black hole, it can be torn apart, emitting X-rays in the process. Black holes also have a massive impact on their surroundings. They can consume nearby stars, release powerful energy bursts, and even influence the formation of new stars in some regions while slowing it down in others. But where do black holes come from? Picture once magnificent stars exploding in a dramatic event called a supernova. From the remnants of these fallen giants, black holes are born. Most black holes emerge from massive stars that have reached the end of their lives in a supernova explosion. Smaller stars, when they die, become neutron stars, extremely dense objects, but not dense enough to trap light. When a star is several times the mass of our Sun, it collapses under its own gravitational pull, forming a black hole. However, as powerful as these collapses are, something strange happens near their surfaces. Time itself starts behaving oddly. From an outside perspective, time seems to slow down near the event horizon, the point of no return for anything falling into a black hole. It's as if the star's clock ticks at a different speed compared to our own. Sometimes, when two smaller black holes collide, they merge to form an even larger and more terrifying black hole. If a black hole interacts with a neutron star, it creates a situation that defies comprehension. Scientists have been trying to grasp the scale of these cosmic anomalies for decades. Black holes come in two main sizes: small and large. However, small is relative when it comes to black holes. The remnants of massive stars can be 10 to 100 times the mass of the Sun. There could be anywhere from 10 million to a billion of these in the Milky Way alone. A staggering number of black holes capable of devouring anything in their path. But wait, there's something even bigger. Supermassive black holes exist at the opposite end of the spectrum. These black holes are millions, if not billions, of times more massive than the Sun. They sit at the centers of gigantic galaxies, including our own Milky Way, acting as enormous voids pulling everything toward them. The famous physicist Stephen Hawking spent much of his life studying black holes. His insights were profound, though some of his theories couldn't be confirmed due to a lack of necessary technology. However, hope is on the horizon. A single scientific instrument is making a massive difference, and we're not ready for it yet. It's called the James Webb Space Telescope, JWST, and it's here to explore the deepest parts of our universe. Let me tell you, the JWST is no ordinary telescope. It's an engineering marvel, a testament to human ambition. Sure, we've launched other space telescopes before and they've done a good job, but this one is truly groundbreaking. The JWST makes the Hubble Space Telescope, which has served us for decades, look like a mere speck in the universe. The price tag for this cosmic wonder: a staggering $10 billion. Yes, you heard that right. Enough zeros to make your head spin. NASA, the European Space Agency, and the Canadian Space Agency joined forces to bring this marvel to life, along with contributions from over 300 universities. But let's not forget the risks involved in such an extraordinary endeavor. The JWST is venturing into the unknown, pushing the boundaries of what we know, and taking us to places we've never imagined. The JWST is not just another telescope, it's a time machine. Unlike Hubble, which primarily observes invisible and ultraviolet light, the JWST specializes in infrared astronomy. Why is this important? Because infrared light can penetrate dust clouds that obscure distant galaxies, allowing us to see objects that were previously invisible. This means JWST can peer further into space than ever before, effectively looking back in time to the earliest galaxies that formed just a few 100 million years after the Big Bang. Scientists hope to answer fundamental questions. How did the first galaxies form? What do exoplanets look like in detail? Could we detect signs of life in distant star systems? But what if JWST discovers something truly unexpected? The black hole hypothesis. Are we living inside one? One of the most mind-bending theories proposed by some physicists is that our entire universe might be inside a black hole. If true, this would redefine everything we think we know about cosmology. Here's the idea. Black holes aren't just destructive voids. They might also be gateways to other universes. When a massive star collapses into a black hole, a singularity forms, a point of infinite density where our current understanding of physics breaks down. Some theories suggest that instead of matter being lost forever, it could be reborn in a new universe. If that's the case, our universe could be the result of another universe's black hole collapse. This concept ties into the multiverse theory, suggesting an endless chain of universes, each born from the singularity of another. Could the JWST provide evidence supporting this? Some scientists speculate that by studying the cosmic microwave background radiation, the faint afterglow of the Big Bang, the JWST might detect anomalies hinting at a black hole origin. If we find distortions or unexpected patterns, it could mean our universe isn't a closed system but part of something much larger. The future of black hole research. Even beyond JWST, new technologies are on the horizon to further unravel the mystery of black holes. The Event Horizon Telescope (EHT) recently provided the first-ever image of a black hole's event horizon, proving Einstein's predictions right. Future advancements in gravitational wave detectors could help us understand black hole mergers and their role in shaping the cosmos. As we push deeper into space exploration, one thing is certain: black holes are no longer just theoretical. They are real, powerful, and possibly the key to understanding our universe's true nature. So, the next time you look up at the night sky, remember, somewhere out there a black hole is silently shaping the fate of the cosmos. And maybe, just maybe, our entire reality is caught within one. Just longed for. After a fruitful send-off, NASA as of late declared that the telescope has sufficient fuel to endure over 2 times its base mission life. Since its send-off, the JWST has proactively accomplished innumerable unfathomable accomplishments, going north of 1 million miles to arrive at its circle around the Sun, where it will remain endlessly. During its excursion, the telescope effectively conveyed its huge 5-layer sunshield and enormous essential mirror, both of which had to be collapsed to fit onto the send-off vehicle. Since NASA has adjusted and changed it, the telescope is practically prepared for full activity. One of the most intriguing parts of the James Webb Space Telescope was when NASA announced that it had captured its first images of starlight. The main picture taken by the telescope was of a star called HD 8446, bringing about a mosaic of 18 dispersed brilliant spots from the star's light, caught by the 18 mirror fragments on the essential mirror. NASA later delivered another genuinely surprising picture of HD 8446, in which the 18 unfocused copies of the star were consolidated into a hexagonal arrangement. Once the observatory effectively adjusts the singular portions of the essential mirror, it will begin the image stacking process, joining the 18 images into one clear view. Thanks to its state-of-the-art innovation, the JWST will assist specialists in studying the beginning phases of the universe after the Big Bang. It will zero in on what occurred after the first stars formed, a period known as the epoch of reionization. This period refers to when neutral hydrogen was reionized, made electrically charged again by radiation from these first stars. This includes looking back billions of years, which is only possible with a powerful telescope like the JWST. The telescope will also assist scientists in finding exoplanets, which are incredibly hard to detect due to the way they interact with their host stars. Its powerful sensors will be able to observe these planets in more detail, including imaging their atmospheres. Understanding the conditions and states of planets could help researchers better predict whether certain planets are habitable. Beyond studying the development of galaxies, researchers are also analyzing how matter is organized on a large scale. This, in turn, allows us to see how the universe has evolved. The twisting and curved galaxies we see today developed from different shapes over billions of years. One of JWST's goals is to look back at the earliest galaxies to better understand their development. Scientists are also trying to determine how we ended up with the range of galaxies visible today and the current processes by which galaxies form and accumulate. But above all, the James Webb Space Telescope will help us answer the most fundamental questions of all. Are we alone in the universe? Are we living inside a black hole? The JWST has already been on the hunt. And guess what it found? Compounds called polycyclic aromatic hydrocarbons, PAHs, around those gigantic supermassive black holes in 3 active galaxies. These carbon-based molecules with ring-like structures are like the goth children of the universe. They're everywhere, from distant galaxies to comets in our solar system. Now, they're not just interesting because they could be the building blocks of life, but also because they help astronomers track star formation. When ultraviolet radiation hits these PAHs, they glow and emit infrared light, a signal that can be detected by the JWST's mid-infrared instrument, MIRI. This often indicates the presence of hot, young stars. But wait for the twist. Astrophysicist Ismail Garcia Bernit from Oxford University decided to study 3 active galaxies, NGC 6552, NGC 7319, and the famous Stephan's Quintet, millions of light-years away. What Garcia Bernit found will make your hair stand on end. In the central regions of these galaxies, where black holes reign, he discovered a mass of PAHs. Sounds fascinating, right? But here's where it gets chilling. The radiation near those supermassive black holes distorted the PAHs, transforming them into larger, electrically neutral versions of themselves. The smaller, electrically charged PAHs evaporated into nothingness, like being consumed by the very darkness itself. But wait, there's a glimmer of hope. Or maybe not. The ultimate question here isn't just whether we're alive, but whether we truly exist. Does everything around us exist because of the black hole we're in? Everything connects to the theory that maybe we're not just living inside a black hole, but inside the event horizon, the boundary between the universe we know and the unknown. Could it be that everything is interconnected within a black hole? The James Webb Space Telescope is out there right now, searching for answers to the unknown. Stay tuned because, just maybe, it will make us all rethink what we thought we knew about existence. Reality may be far more twisted than we realize. As the JWST continues its mission, it will push the boundaries of our understanding and possibly answer questions we've been asking for centuries. It's not just a telescope, it's a window into the profound mysteries of the universe. Its discoveries could not only reveal the secrets of black holes and exoplanets but also help us understand our place in the cosmos. Will it answer whether we are truly alone? Will it help us find other living beings, perhaps hidden in the depths of space or in the atmospheres of distant planets? The JWST's powerful instruments are capable of probing far deeper into the universe than any telescope before it, uncovering patterns and phenomena that were previously invisible. It's a tool that could change everything we thought we knew about the universe, gravity, and even time itself. The more we understand black holes, the more we may realize how interconnected everything in the universe truly is. Perhaps we are all part of a larger cosmic story, one that the JWST is only beginning to unravel. Yet, the answers it uncovers won't come without more questions. The more we learn, the more we might question the very nature of reality. Are we simply part of a grand cosmic experiment? Or are we, as we appear, part of a greater plan, one that stretches across dimensions we can't yet comprehend? The JWST will be at the forefront of this inquiry, examining the universe in ways that challenge our imagination and understanding. Moreover, the telescope will likely change the future of space exploration and the way we perceive galaxies, stars, and black holes. As we move further into the unknown, the JWST promises to help unlock the deepest corners of space, perhaps allowing us to understand things like the Big Bang, dark energy, or the true mechanics behind gravity. It's a thrilling thought that, with the aid of this extraordinary machine, humanity could uncover answers that have eluded us for centuries. As we watch its discoveries unfold, one thing is certain. The James Webb Space Telescope represents humanity's hunger for knowledge, our relentless curiosity about the universe, and our drive to understand the unknown. It's more than just a project or an instrument. It's a reflection of who we are, a species looking to the stars not just for answers but for understanding.